Additionally, we'd love to hear from HP this morning. I'm proud to introduce a couple of great leaders from the industry who are talking about both HPC as well as data center automation and the futures that are going on in enterprise IT. And we're really proud to have these folks come out. They're well known within the industry and have a lot of interesting thoughts to share with you today. So we'll start off the morning with a keynote from HP. We have with us today Jérôme Labat, who's a vice president and general manager with HP, as well as Dick Bland, who's in the HPC division and does a lot of the efforts with marketing for the HPC for HP. So with that, we'll introduce Dick, and thank you, HP.
Thanks, Chad. Well, good morning, everybody. Hope you had a good time last night. I certainly did. Yeah, we're going to cover a lot today in this keynote. We're going to start out with what some of the things that we're doing in high-performance computing, follow on to what we heard yesterday from Bill about Intel's new Xeon Phi coprocessor, talk about some new innovation that we've got around storage, particularly scale-out storage, and then talk a little bit about Moonshot. The launch for Moonshot was on Monday. I don't know if you heard the announcement or not, but we will talk a little bit about that. And then I'll turn it over to Jerome to talk more about what HP's doing around cloud and data center automation. So we'll start out with what we're doing around high-performance computing, particularly around our SL line. The SL line is our high-performance computing purpose-built server line, and this is where you will see, all of the accelerators, whether it's the Xeon Phi coprocessor or the new Kepler NVIDIA GPUs. We start out with the chassis, and then in that chassis, we can put any one of these different trays. They're similar to blades, only instead of being vertical, they're horizontal. 230 is a compute module, two Xeon processors. Then the SL250 will take up to 3 accelerators. Again, those can be Xeon Phi or the NVIDIA Kepler. And then the last one here, the SL270, holds up to 8. So that means in a single 4U enclosure, I can get either 12 or 16 accelerators. We finished that off with our Mellanox ConnectX 3 14 data rate InfiniBand, and that's how we're going to market around accelerators. I wanted to tell you about a company that is using this in a very innovative way. I put innovation in between HP and the customer. The customer is an innovative, smaller company, not a big company, but that's what I wanted to show is that, you don't have to be a Fortune 500 or a national lab to take advantage of accelerators. You can be a smaller company and still take a lot of advantage of this. Microseismic is a leader in passive seismic monitoring in the oil and gas industry. And what they're actually doing is when they do a massive hydraulic fracturing or fracking, they're able to listen to what is happening and then process that data and give the people that are drilling the well almost real-time information on what's going on with that fracturing. And so they came to us and said, we've got a tremendous increase in the amount of data that we need to process. And so we worked with them to put in an SL250, us and a reseller that we work with in Houston. And what we came up with is an HPC solution, cluster solution, that uses Moab to manage this cluster as a grid. And actually, now they have 2 clusters, one in Houston and one in Denver, and they're managing that all as a grid, and they're running thousands and thousands of jobs through this every day. And what they found was that they were able to get an 8x speed up in processing throughput for these jobs, and as a result, they've been able to increase their revenues, they've been able to grow their business, and they're turning better service to their customers. Now, the other thing about this, and this is another thing that people need to take into account, is that they're not just doing this faster, they're doing it at 50% less power than the solution they had before, and with the management tools that they've got with Moab and our tools, they're able to do this much, much faster and with a lot less people. And this is up on the HP website, or if you just type in HP microseismic into Google, you'll find that solution. So again, this is our new lineup for accelerators. We support both the Intel Xeon Phi coprocessor as well as the new K10 and K20 Kepler GPUs in these SL servers. And these are available today. I heard from Intel that people were asking about availability of Phi and Xeon Phi. And we actually have a starter kit that we put together with the Intel folks. It's a complete cluster. It's a starter kit. So it has 4 of those SL250s, each with 2 GPUs, a head node, an InfiniBand network, as well as a ProCurve management network, Red Hat Linux, comes with CMU. It comes with our new workload optimization pack, which features Adaptive's Moab HPC suite, as well as Intel Cluster Studio. So you can order this, and you can get started doing Xeon Phi very, very quickly. And if you will come up and ask me afterwards, I can get you some information or get you hooked up with someone to get more information on it. This is another thing that we're doing around enabling manufacturing innovation, and this is really all about cloud and cloud transformation for the manufacturing industry. We see a lot of tier 1 manufacturers, Ford, Boeing, Airbus, that are taking advantage of high performance computing. But what we want to do is enable people at the next level down, the SMBs, the small to medium businesses, to be able to take advantage of those same things. So we've come up with this Innovation Hub program, working with academia and some regional innovation centers to set this up where, through Moab and Insight CMU, I don't know if everyone was able to attend Andy's session yesterday. If you weren't, I highly recommend that you tune in to the replay of that and hear more about CMU and some of the great things that we're doing there. In addition to that, we also have servers that are visualization enabled, and with those servers, we're able to deliver, high-speed, remote, 3D interactive graphics back to users wherever they may be. Let's shift gears a little bit, and I want to talk about another new innovation that we just came up with recently. This is our first HP storage server. Now, this is not meant to compete with the products from our HP storage division. They have products, in the enterprise space for, databases, Oracle, SAP, those kinds of applications. This is really intended for a whole new class of applications. So this is OpenStack, a lot of OpenStack applications, software-defined scale-out storage. And what you're looking at here is the 1 by. So this is actually an SL server over here on the right, and then in this enclosure, this is a 4.3U enclosure, and in this enclosure, there are 60 drives. So what that means is that with our new 4 terabyte drives that just started shipping, I can get 2.2 petabytes of storage into a single 42U rack. And this is for people that are doing, scale out storage, OpenStack storage, whether it's Swift or Ceph or, we're working with all of these different vendors on cloud and object storage here. When you get into the higher end, we've got 2 nodes with 25 drives each, and then 3 nodes with 15 drives each. And each one of these is tuned for a particular workload, whether it's Hadoop or open source OpenStack databases or Vertica, which is our HP product, and that's something more in the realm of what Jerome will talk about in his part of the talk. Now I want to talk a little bit about Moonshot. This was what was launched on Monday, and this is being referred to as a software-defined server platform, and I think you'll see here how we're really going to accelerate innovation to deliver even greater efficiency and scale for applications. So what we're seeing here, this is really the gist of what we wanted to talk about, is a whole new style of IT is emerging. We've got our traditional data centers, as I said, running all your traditional applications, but, the world is changing, whether it's mobility or cloud, social media, social data, or big data, there's a lot of market growth here, and a lot of comprehensive solutions are going to be needed to really service this new market. So if you think of it, every day we're changing the way that we do things. We've gone from, back here, this is really today, to where we'll be by 2020, and the growth is massive. And it really has to do with all of the different devices, the different things that are connected to the internet. Everything's connected. Smart devices continue to expand, and we're seeing just this exponential explosion of information. This really calls for a new style of IT to develop solutions for this space. And that's where we came up with Moonshot. Scale out. We want to be able to scale to, dramatic new levels that we haven't been able to do before, but still stay in that same energy and space envelope. We want to be able to do this faster. And we want to be able to do specialized, based more on workload and what the application wants to do rather than just starting with a base platform. So if you think about this, today, here's how we do things today. We've got this industry cycle where we get a processor refresh, and then based on that processor refresh, we, then roll our entire server line, and then people come along behind that and start to layer solutions in on a common architecture. So the difference is with Moonshot is that, you're going to identify a new market, you're going to analyze the applications that are going to be needed for that, and then you're going to optimize this cartridge design to come up with a disruptive solution to go after that particular market. So that was really the thinking behind Moonshot, and this is actually what Moonshot will look like. That should look familiar. That's that same chassis actually that I showed you earlier for that storage server, the SL4500. And again, what we've done is taken all of the power and cooling and put it into the back, along with all of the networking. There's 2 switches here, and in this one enclosure, I'll be able to get up to 45 servers. And the servers will be, for a particular workload. The one that was announced on Monday is targeted for web front ends. So this is actually a Moonshot server cartridge. And again, you can get 45 of these into this 4.3U enclosure. And you can see the processor here. Hard drive would go here. Memory goes here. And this is what people are looking for, especially in the service provider market, for web hosting, web front end, things where I don't need a lot of compute power, but I do need a lot of servers. So we really want to make sure that we're enabling you to tackle any challenge. A lot of things going on at HP for HPC solutions. You're going to hear a lot more this year about other aspects of this Moonshot program that will really change the way we do things with high-performance computing over the next couple of years. So we want to do this faster, make sure that we're doing converged infrastructure, purpose-built for high-performance computing and scale. And we want to do it better so that we can optimize your performance footprint as much as possible with the most efficient systems that we could make. And we want to be able to do that smarter. We want to deploy it easily, quickly, and improve service of quality of service. And I think that kind of leads into what Jérôme was going to talk about. So I'll turn it over to Jérôme.
Oh, thank you. So what I wanted to do in the next 10, 15 minutes is to kind of look at all this innovation that's happening at HP from a hardware perspective and kind of bring it up a little bit and look at what it means, what are the implications from a management perspective. So in my old world, I used to actually be in the ops side of the house and run some of the shops. So I have a keen affinity to what's happening and the impact of this new style of IT on the IT operations environment. So first and foremost, what is this new style of IT? What does this mean? And if you think about, I don't know if you follow Jeffrey Moore and some of the work he's been doing, but he talks about system of records and system of engagement. System of records is really your traditional ERP system, your monolith environment where everything comes in, you have a specialized infrastructure, specialized dedicated workforce, specialized applications, and you basically use command line to operate and manage that. And from an IT perspective, the defined workloads. So you know how to look at them, you know how to operate them, you know what to monitor, what to look at. The system of engagement is a very different world. It's really the transformation of users using IT services and new system in a context of social, mobile, where you don't expect to write a command line to tell the software what to do. You actually expect to pick up a mobile phone and have the software know who you are and react to your behavior, understand your location. A very different experience. Think about your 2-year-old looking at, an iPad and flipping through the iPad with his finger. Think about that 2-year-old in 15, 20 years in the IT operations world. He's not going to expect to write a command line. He's going to expect to go get the software and actually have the software perform what it needs to do. So it's a very different experience. And that actually has a very strong transformation or impact on how you do your job in IT every day. Because you still have to run and operate the existing environment. It doesn't go away. 90% of your revenue, your business, runs on this existing monolithic environment. However, new workloads are coming into the data center and you need to support those. And what we try to do is we try to structure those type of changes or transformation, that parallel or represent what this new style of IT is. And if you think about what you do in IT, the first thing is you manage information. You're all about managing data. So in a traditional environment, what's going to be is basically your business intelligence, your relational data, very structured data. In this new world, it's all about feeds, instant on, videos. It's not just your relational data. It's actually it's data that's going to sit in any kind of format that you want to be able to go look at. So that's why we call it multimedia. So from structured data to unstructured data to multimedia data. And you need all this feed, you know, all this analysis, because you need to be able to better understand and tune your products as your users are evolving and changing and reacting almost real time. From an engineering process perspective, it's not just about technology, it's actually how you build application, how you deploy application, how you operate your environment. If you think about the concept of DevOps today, where an engineer can go in the morning, write some code, and in the afternoon or at night release that code in production. That's pretty scary for an IT operations environment where you're used to have a no-touch environment. So how do you go from this, you know, waterfall approach to building software, waterfall approach to IT operations to this like instant on, rapid evolution, rapid deployment, always on kind of environment. So it's transforming how we do things, how you build application, how you support application. Major shift here again. From an applications perspective, in a traditional environment, you understand the characteristic of the application of the infrastructure. In this new environment, you actually need to change how you build your application. You have to build for failure. You have to understand that the environment, the resources, infrastructure or software might not be available all the time. And for making sure that your application or service performs, you actually have to design your application in a distributed manner, and that's actually going to be designed for failure. It's a very different mindset on how you look at your application. It's also a different mindset on how you operate them. Because now it's not just about understanding the, 99.999 performance or assurance on your system. It's actually working through a whole stack of components that are all distributed and connected together that might not all work together at the same level. So big shift again on how you're going to operate those applications. The shift on information, the type of information, shift on processes, shift on how the applications are actually built. And think about infrastructure, which is actually the one that's the most common understood today, because everybody talks about AKA cloud, an infrastructure as a service, the ability to get it through an API. It's just the foundation of one of the core shifts. So if you look at this whole stack, and you look at what's happening on the left in the traditional world and what's coming in this new style of IT, the impact on IT operation is phenomenal. Because you have to change your processes, but you're going to also have to change your technology. And so what we've done at HP is we've been really listening to our customers. In the IT management space, we have a lot of products that help us, operate and automate a data center today, understand the workloads, how they perform, application performance, etc. And what we did is we tried to put a framework together that says, if this is a new style of IT, this is a new types of workloads, a new type of behavior from a user perspective, the new types of applications, what is it that I need to do to be able to operate that environment? So, what is operation? It's about understanding what's happening in your environment. Once you deploy the workload in your environment, you need to understand what's happening. In the traditional world, because we had this monolithic approach from infrastructure up all the way to the service, you actually knew what to look for. And you instrument the infrastructure or instrument the application or the service specifically to what you feel is going to fail. And this is why, in this case, you manage what matters. Because you understood the constraint and you know what to work after, what to look for. In the context of, the web, as applications started to be more distributed, you still understand a little bit less of what matters, but you have a good and, have a point of view. What you do have is a set of systems that are starting to come together because it's distributed. So from an operation and IT perspective, it's no longer just instrumenting one point, one application, one system, one infrastructure. It's actually starting to instrument multiple of those. And you need a level of correlation. And so what you saw happening in the 2000s is really this new type of capabilities where you model your system or your application or your workload, and then through some level of, correlation, you actually understood what's happening in your system. And we have a set of products out there that demonstrate that on a day-to-day basis, where we have, a runtime CMDB. It's a runtime model that understands how a system or service is deployed and how it's running, and you can actually correlate all the CIs, the specific elements that compose that system. Going forward in this new style of IT, not only you have this highly distributed environment, but now you actually have feeds that come from multiple sources. Think about sensors on your fridge, in your cars, for those applications. Think about sensors in your phones. And Think about sensors for security, instrumentation in your application, instrumentation in your infrastructure. I mean, everything talks now. All the systems talk. They all are a smart system. And this onslaught of information that's going to come to IT is just incredible to manage. And there's one set of technologies out there that are going to help us actually start to make some sense and understand what's happening here. So we believe that, from an IT perspective, this curve is just going to continue to accelerate. Doesn't matter what section of the business or, industry you're in, this is just going to be an ongoing spike. So what do we need to do? And how are we going to handle this amount of data, and how are we going to actually leverage it to better operate your environment? Because at the end of the day, from an IT operations perspective, IT management perspective, I need to understand my workload. And my users don't really care where it's coming from and who is running it. They want the right SLA. So what we did is we put together this framework that's going to allow us to, in essence, stack analytics. Because at the end of the day, the way we're going to solve this problem is through, with data analytics. And we looked at the different types of analytics that are available today. And some of this, in some of this framework, we actually have solutions today that are running. So if you think about how we look at the problem, oversight. Oversight is about understanding the financial state of your business. So I'm in IT and I'm running IT as a business. I need to understand how I'm doing, how am I satisfying my customer? Am I patching in time? Am I compliant? Do I have the right level of, cost structure in my environment? Am I providing or brokering the right resources at the right price point to my business partners? So this is really about understanding the business value. It's really more the financial analytics. That's the oversight side of the house. The foresight side of the house is actually an intriguing one, which has been evolving from this correlation concept. If you understand your systems, and you understand and you can analyze the behavior of the system, of the applications over some time, you can actually start to predict the behavior potentially of those applications and those workloads. And we have some products and solutions today that exist. I mean, we have a customer that's been testing some of the new products out there, and we were able to predict within 3 or 4 hours in advance of the event what was going to happen and how this workload was going to be actually impacted with some use. We use a lot of our labs folks. In HP Labs, we have, some pretty smart scientists out there, data scientists, and we've been leveraging a lot of their algorithm to do some of that work. So what's interesting here, you start to see a correlation with the high compute type environment, because it's no longer just looking at the data, but it's really inferring a set of behavior out of that data as we go forward. So foresight is, how is this going to happen? Capacity management, et cetera, et cetera. Insight is about what's happening now in your application, in your workload. It's truly understanding real-time how your application is performing. It's understanding, potentially your security threat, your risk in your environment. And this is, again, something we've been doing for many years. It's just becoming more complex now because you have so many more feeds. But you still need to understand how your workloads or your applications are performing today. And then finally, hindsight. What happened? When you have to go back to your boss and say you had a major meltdown, you have to be able to articulate why there was such a meltdown and where it came from, and what are you going to do to recover that? How are you going to solve the problem going forward? How are you going to apply some of those learnings? It's just the real world. So we think that using analytics, using the concept of big data, we can actually change the game and stay ahead of that curve, from an operations perspective, so that we can actually deploy those new types of applications faster. We can actually understand how they operate better, and we can provide the right set of services or level of services to your business partners. And my last slide is really about kind of helping you frame and deep dive a little bit on how those things come together in terms of the technologies that exist today. Now, if you look at the IT operation, it's all about solving problems. You have known problems and you have unknown problems. And the reality of this new environment is you'll have a lot more unknown problems over time than you'll have known problems, just by the nature of this new type of applications. If you broker services and you don't own, for example, I'm going to go to a public cloud service, and I don't have access to what's powering this public cloud. I expect this public cloud to provide me a set of SLAs and behavior. from an operations perspective, I have a set of risk of unknown problems just by the nature of the fact that I'm connecting to a public service. By the way, it could be a private cloud internally, it could be a different division, same types of problems. So known problems, unknown problems. Then from a monitoring, which is really the key to operations, understanding how things are going, you're going to have proactive monitoring and you're going to have reactive monitoring. And what I mean by proactive is like you actually have sensors and analysis and, what we call prediction, predictive behavior, and we're going to look forward. Reactive is I have instrumented a set of events because I know what the problem is, and I'm going to get alerts, and I'm going to see that in my NOC, and I'm going to be able to look at that. So if you look at the set of technologies that exist in that space, the intersection between the known problem and reactive monitoring is basically your traditional instrumentation. That's what we've been doing for years. And we can do more, we can instrument more as you learn, and you have learning of failures and events. You start to add that to your libraries, and you can, have more events discovery and triggering more insight in terms of what's happening in your environment real time. The proactive monitoring is really about this, what I call the correlation or the inverse correlation. So being able to look at the system, we have models today, we have the way to do it today, so we can understand what's going to happen, and we can start to predict the behavior of the workload, the use of your infrastructure, the behavior of the applications. And then for the unknown problems, the only technology we really have today is looking at logs. If you think about what's happening in your infrastructure, if you think about what's happening with your applications, what you do is you instrument your application, your infrastructure, and you feed data. And you look at your data real time. Think about a security use case. How do you look at intrusion detection? How do you notice that something is happening in your network? How do you know that your application is under attack? Because you're looking at the logs. You're looking at all those feeds that are coming in. So really we call that log management, in that case. So going forward, thinking about IT operations and IT operation analytics, what we want to do is we want to take all those elements that exist today and actually move them to the right, which is what we call advanced analytics. So being able to not only look at the logs, but apply the understanding of what's happening through this correlation, plus the known issues, and bring those together and actually introduce smarts into this analytics so that we can be a lot more adaptive. We can be a lot more reactive in what's going to happen with those new applications. Because a lot of those new style of IT, in essence, is going to introduce a lot more unknown problems in the environment. And we think that's a challenge going forward at scale. So, to summarize, we have a big challenge from an IT management in front of us. We still have to operate the existing world. It doesn't go away. We have to accelerate the deployment and operations of those new types of applications. We have to change our internal processes to actually help those engineers build applications faster. And I have to bring them all together because at the end of the day, I need to go back to my business and show, fiduciary responsibility and accountability on how I run my shop. So we do believe that by pushing the envelope and looking at analytics and this, big data type of approaches, we're going to be able to solve some of those problems. And we do have products out there today that are demonstrating those components, and you'll see more coming forward. That make sense? That's pretty much the topic for what we think is happening today. So, can I open it for questions?